great to see everybody here after 2 years of lockdown and COVID. And it's nice to be able to get to see old friends and colleagues again.
Doesn't it?
If we all jump to the lifeboats, it's okay.
So, firstly,
we are working our way.
That's another sort of energy sustainable technology that sort of is great but works against us. It also burns the grass in my yard.
I'm Brent Brooks. I'm from Toronto, Canada. We have quite a good high-rise program. I had a fire back in 2010, and in 2010, I thought I knew everything there was to know about high-rise firefighting. You couldn't teach me one more thing about high-rise firefighting. And do we have firefighters in the room here? Or just a show of hands? Oh, perfect. So I am boots on the ground firefighter. I'm a captain of the high-rise unit. I go to fires. I love my job. I love getting dirty, and I love teaching what I know. But I know in 2010, our bad fire, and I thought I knew everything there was to know about high-rise firefighting. And if you ever get a point in your career where you think you know everything, it's time to check yourself. It's time to go to a conference. It's time to get motivated again. And I see Ed here. I think you might be a little bit older than I am, but he's here and he's learning and he's been here. And I see experts in the audience, and you're still here learning. So that was my experience. Is I got rechecked in 2010. I'm going to talk today about some of the tactics that we do in Toronto. Some of the tactics you're not going to like. It's a big change. We're using large diameter hose. We're using a lot of volume of water, and it's made a big difference in us. The firefighters that are here, have you had a bad experience with nozzle reaction on a 65 millimeter hose line? Yeah, certainly you have. You've been pushed back, you've fallen down, you've staffed up on it, you've put 4, 5, 6, 8 firefighters on a 65 millimeter hose line, and you've really struggled with it. And it's hard for us to make that change. This is the biggest change in the Canadian Fire Service, the biggest change. And I'm going to talk about it. And it hasn't been easy. That's my bio there. It's in the program. So let's skip that. That's the high-rise truck that we have in Toronto. It was running 5,800 calls a year. We've added a second high-rise truck. It is just as busy. And what we did was we started taking it off of alarm calls, and it only goes to fires. So we went from 5,800 calls a year, and now we're down to 2,200 calls a year. But those are fires that we're going to. It has no pump. It has no ladder, but it has the equipment that we need for high-rise firefighting. The big fans, the 30-inch fans, stuff from falling debris. 3 years ago when I was here, I talked about the high-rise truck. I talked about the type of equipment that was on the truck. And what I did way back after 2010 was I took all 12 problems with high-rise firefighting. We came up with a plan A, a plan B, and a plan C, and the equipment to go with all those plans. So we have multiple options when plan A fails, when plan B fails, and we have options now up to plan F. When we did pick our hose and nozzle package, I first started studying what we do in Canada. Paul Grimwood's not here, but I wanted, it's too bad, so I got his book, and you can see it's very well read. And it's very well studied. And after I studied what happened in North America, I started traveling the world. And if you could take a picture and just send that to Paul, because I think he would really appreciate the change that he may not know that he's made in my life and the Canadian Fire Service by the good things that he's mentioned. And I'm not sure on my interpretation of his reading, But let me explain. So I took this from his book. It's a shot here. And I added the scenarios. I added those numbers there. But I wanted to know what type of hose and nozzle package are we using for those 6 type of scenarios. And I wanted to know how many liters per minute we were flowing on our fires in Toronto. So what type of hose and nozzle package am I going to use for each one of these scenarios? And you're going to be surprised, probably, and it's going to sound out of sorts with you, but we were flowing 500 liters per minute on our fires in Toronto. The bad fire that I was talking about, it was an 8-hour high-rise fire with structural damage, contained to 1 unit. It took us, once we lost door control, it took us 5.5 hours to get back to that fire department. The high-rise crew, which was my crew, we had all the maydays. We're the ones that got into trouble, and that's what changed our life. We're flowing 500 liters per minute, and we've had multiple fires since. I've been logging those, I've been tracking those, and we switched to a 65 millimeter hose, and we're flowing 1,003 liters per minute off our initial attack line now. If you look at Paul's fire, we were fighting 1 room and contents. Now we're doing a rapid knockdown. What's cool and interesting about the 65 millimeter hose line is I can now fight a big fire, but simply by changing what's on the end of the appliance, I can double my output. So I'm flowing 2,000 liters per minute off our first attack line. If things go south or things go bad, I'm not stretching a new line. The big line's already down, it's already dropped. I'm simply switching what's on the end, and I'm flowing more water. And what a difference does it make? This is what the first 2 crews are taking into a fire. And when I look at this, and again, firefighters that work with the 65 millimeter hose, the nozzle reaction, the weight of the hose, yada, 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 it's difficult. It's frustrating. We've all had bad experiences with it. But I can tell you that I've trained 9,000 firefighters in Toronto. So we have 3,000 firefighters. I brought them for phase 3. So we've trained 9,000 firefighters. And I was the most hated guy on the job, hands down. Hated, hated, hated. Threats, meeting outside the station. And I'm like, you got to understand this stuff. Brooksy, no, you can't. And good friends of mine were like, what are you doing? Like, what are you doing? We need more staffing. We can't put this line into play. We need something more maneuverable to get water on the fire quick. And I can tell you that's not true. We're able to do it. I've been traveling around Canada. I just got back from Calgary last week. The union, the management, we're all frustrated. They're like, what is this guy going to tell us? I said, I can give you a PowerPoint presentation all day long, but firefighters, we don't like that. We want to have hands-on and get on the hose. So we went out on the fire ground, the union, the management, the health and safety, and we started moving 65 millimeter hose, and we did it effortlessly. Now, how did we do this? We hire 100 recruits at a time in Toronto. We have a daytime and a nighttime class, and that's not going to stop for the next 4 years. So we're 650 firefighters short. The retirements are happening now in the city, and this isn't going to stop. We're going to have a day and a nighttime class. What I noticed when we train our firefighters, the day and the nighttime class, was I get to see how you move hose. I get to see firefighters in all different shapes, sizes, and physical abilities. In my case, it's age, move this 65 millimeter hose. And we talk about in New York City, having 5 firefighters on an engine company, and that's great. I love it. We talk about bump and push-up positions in moving hose, and we've done something a little bit different in Toronto, and I'm going to explain that in a second. But in order to do that, I had to look at weights. Our kit weighs 22 pounds. The hose dry weighs 20 pounds. If I'm standing with the hose at the nozzle section, it weighs 30. If I stand midway and pick the hose up, it weighs 30 pounds. When I do, just borrow this chair here. Oh, it's attached. When I do a high heat, low drag, I start at 30 pounds. And worst case scenario on a 50-foot hose line, it goes to 80 pounds. Well, this was interesting to us because it is at least in my career, an unmanageable, unmovable hose line. But we started putting the science into it, and it really changed our fire service. When we look at that high heat, low drag from the 30 to 80 pounds, we look at the average size of an adolescent that weighs 80 pounds. One firefighter should be able to move 80 pounds. We look at we have a drag rescue device on all our bunker gear. It's the same concept when we drag a firefighter, although a firefighter will weigh much more. It's the same position. We looked at advanced hose and nozzle movements, like nozzle forward. It's a great course, a lot of advanced stuff in there. Well, we simplified that even. We didn't take all those complicated movements that you have to work as a team, you have to work in unison to move this big hose line. By watching our recruits, we had 5 on the line, we had 4 on the line, we had 3 on the line, and at 2 firefighters on the line, we were able to move that hose line easier. And this is where you're thinking, this guy's crazy up here. We're still going in with 5. We still heavily staff our first in apparatus on a fire. We don't go in with less than 5, but we put no more than 2 firefighters on that hose line. We made a prop that is made out of Lexan. It's crystal clear. We put 4 pinch points. On average, we're getting 2 pinch points in a high-rise fire. We wanted to double that. We made the hallways tight and narrow and difficult to move. And we showed how we can add to the front section. We're no longer moving 200, 300 feet of charge 65. We're only moving 50 feet at a time. We add it to the front. On average, we are less than 50 foot short on a high-rise fire when we're doing a hallway stretch or the floor below. We're only adding the 50 feet. And we have videos. It's made a big difference. So I was the most hated guy on Toronto Fire, and now I'm the most liked. We have a union forum. We have comments, and it's changed. I'm getting calls now from firefighters. Thank you. I'm sorry for what I did to you back in the day. I apologize, but you've made a difference, and we're going to talk about some of that. We had to look at what we were flowing. So we're running 350 kPa nozzles in Toronto, and I hope I did the bar calculations right. So 3.5 bar here in Britain, 50 PSI in the United States. Our building code only guarantees us 450 kPa at the valve outlet. So on a hallway stretch with 2 lengths, that's 100 feet, and our nozzle package, we need 450 kPa for a hallway stretch. If we go floor below, we have to add another 50 feet, but now we need 535 kPa. The 35 kPa I don't believe is right. I think it should be 40 kPa, but when we set our gate and gauge, it doesn't matter. And if we know how to take nozzle reaction to ground, it doesn't matter either. And what was happening, and firefighters were all in. And if I see a hose line on the ground, and I come up, and the crew's making entry into this door, and we have a nozzle firefighter, we have the backup firefighter, we have our tick, and I'm not doing anything, right? I'm waiting for something to do. I'm going to pick that hose line up, and I'm going to help that crew advance that hose line. And when we do that, it slows the forward progression down. Because when I lift that hose line up, it's a big hose line, it's heavy, I end up giving nozzle reaction to the next 2 firefighters. And I'm going to show you how we back up. If I want to do something, I'm the 3rd firefighter, I just need to put my foot on the line. It's neat stuff. We also had to look at our standpipe debris. And because we're using 65, the largest thing I could find to put through a 65 millimeter hose was a golf ball. I couldn't fit it in, so I had to put a slit in the line and actually flow water through it. And for demonstration purposes only, it's very dangerous. It came out at 1400 kPa, it came out at 350 kPa, it came out at different kPas. If you are running a fog nozzle, I know you have dry systems here, so we have wet systems in our city, but we put sunflower seeds in ours, which mimics standpipe degree, tuberculated pipe. Anytime you have oxygen, water, you get tuberculated pipe. But look what we're flowing out of a smaller diameter hose line. We go back to Paul Grimwood's heat release rates and his heat release rate, his flow gradient. We're back down to that 475 liters per minute. That's less than 1 room and content type fire. That's a problem. If we look at our standpipe systems in Canada, that's not my colonoscopy. That is an actual high-rise standpipe system. So we took the NFPA 14, we took 13E, and we took 1710. 1710 tells us if you want to have an effective firefighting force, you need 1,892 liters per minute off 2 hose lines on the fire floor, 946 on the floor above. How do you do that? Well, you can't do it with any hose line smaller in my country unless it's a 65 millimeter hose. So we had to suck it up and we had to start using that hose line. And it wasn't easy because we were moving hose wrong. We do have constant debris. So we're lucky in the city of Toronto. We have well over 3,000 high-rise buildings. A lot of those buildings we own. They're government housing buildings. We have the largest government housing building in all of North America. It's the 200 Wellesley Street, the fire that we got into trouble. We get fires there all the time. We send 7 trucks, even for an alarm call. We constantly get tuberculated pipe. We get 3/4 inch gravel. We have no active volcanoes in Toronto, but you can see we have some volcanic ash and some metal debris. This happens all the time, regardless of the age of the building. If you're using a fog nozzle, you will get it clogged. This is 150 Dan Leckie Way. It's a 42-story building. Again, it's owned by our city. We can go and flow, and we can go and test our science behind this. That's not dye added to the water. That is standpipe debris. And we were flowing for well over 2 hours, and the best color it went was a light brown color. What I liked about that is you can see the fog nozzle, you can see the transparency. We're not getting the punch in the throat that we needed with the fog nozzle. If you look at the NFPA 1710, 13E, and 14, it tells us not to use those type of nozzles. We don't use them. We can easily pass debris now in our city. This is at our training academy. Again, we flow every water. We have a daytime and a nighttime class. And every day on a system that's flushed multiple times, we have standpipe debris. That's called tuberculated pipe. Another big change that we made, and I tell my friends in the US, and I travel to them, I go to HROC, which is the High Rise Conference. I never miss it. I always go to it. And we debate like we do here with our colleagues, and we don't always agree on stuff. And that's okay. And the one thing that they don't agree with us is the water can. So we're bringing the water can into fires for that quick, rapid knockdown, get water on the fire quick. But what was happening in our city is that was getting us into trouble because if we couldn't put the fire out with the water can, we made a mess of the hallway. We're forced to go floor below. Now we make a mess of the stairwell. And our problem is compounded. And they're like, Brooksy, the water can is faster, lighter, and we can deploy it quicker. But then we looked at the science behind it, and if you look back at our old slide, our high-rise packs weigh 20 pounds. The water can weighs 20. Sorry, the water can weighs 25, the hose pack. So our hose packs are actually lighter. We looked at what we can do with a bale position, and it's closed while moving. The water can is a 1/4 bale. For hydraulic ventilation, it's half bale. And if I want to use the full potential of that nozzle, it's the bale open all the way. So we no longer take the water can into fires because it was making a mess of the building if we couldn't put it out. This is our standpipe kit, and this stuff, by the way, is all on my website. I don't charge for anything. I always donate my time, but that's our kit. It's on there, so have a look at it. It weighs 22 pounds. The standpipe system types that we have in Toronto, we have Class 1, Class 2, and Class 3. Our Class 1s are in the stairwells and in the hallways. Our Class 2, which are absolute garbage systems, they're 38 millimeter connections with no fire pump and no FDIC connection. If we have a Class 2 system in our city, I bypass it and we stretch from the truck. Because we have positive control of what's coming from our fire truck. I don't know what these building systems have. Our Class 3, which is the most common system, the one down here on the bottom, it has both a 38 and a 65. We exclusively use a 65. I'm also proud to say is with lots of push, is we're getting rid of the occupant hose in Canada. All our federal buildings have already got rid of it. And again, firefighters say, but I can grab that occupant hose and I can do a quick attack at that fire and get it out. The problem in the 2019 Mayday in Toronto, that's exactly what the firefighters did. They pulled the occupant hose, which is crap. It's not checked. We don't have positive control of it, and it got us into trouble. The occupant had pulled the hose, they left the door open, we now have a dirty hallway, we now have a dirty stairwell, and that's got to stop. And it has stopped. It's gotten a lot better. We looked at our kit, it can hook up to all of our classes of system, but what was important was we needed to be able to do an improvised standpipe. So if I had a fire in this room here, I'd come up with 150 feet of hose. I have a railing right here. I drop one length to the truck. One length of 50 feet hose gives me 5 stories. We actually do the same tactic now at residential house fire, and it's kind of a European thing, to be honest. Normally we stretch from the truck, but this is kind of a European model that we took from France. I'm going to talk about some tactics here. There's a list of it. And what's happened is because we've switched to the 65 millimeter hose line, no matter what tactic I choose, the big line's already laid. I can do all these tactics because I have the big line already dropped. So the 65 millimeter Breslin, the floor below, all this stuff, we're using a big line. So this is, I know Peter's going to talk about it a little bit later. So let me just say, this is firefighting on the exterior of the building from the interior. We have the opposing tip nozzle, we have the floor below nozzle, and we have 65 millimeter Breslins. 65 millimeter Breslin comes in all different shapes and liters per minute. If we're using a 1400 liter per minute Breslin, we're not using it off a standpipe system. We can't get the flows that we needed. We're using 800 liter per minute Breslin distributors for our wind impacted fires, our exterior cladding, and so on. We looked at tons of videos, and this is a good one here. It's a truck company, no hose line. You're going to see the stairwell door get opened here, and how quickly that turns. Now in Toronto, we are staffed up in front of that door with 1,003 liters per minute with a door control strap because of what happened to us at 200 Wellesley Street, and we're putting a quick punch in on that. That's a meat and potatoes for us. That's what it looks like.
Thank you, everyone.
Book your tickets now for the 8th International Tall Building High Rise Fire Safety Conference, taking place alongside FDIC in Indianapolis, US, on the 15th to the 17th of April 2024. 3 days of world-class speaker presentations, debates and networking. Book your tickets via the website www.tallbuildingfiresafety.com. Early bird discount tickets will be available. The Tall and High-Rise Building Fire Safety Management course is ideal for anyone who has responsibility for fire safety management in tall and high-rise buildings. It is a 5-day intensive course with world-class instructors. You can get full details of the course on our website www.tallbuildingfiresafety.com.
This is what happened at Wellesley. This isn't Wellesley Street. I think this is LA County, but this crew goes to make entry into the fire department. It's a wind impacted fire with flow path. They regained door control. They staffed up in front of this with the big line, and just watch what happens here. There's no audio on this, but they're going to make entry into this fire department, and that is bad news. There's no smoke. That is just fire coming at them. But they met it with enough liters per minute for the megawatt type fire that had, and that's a 6-second fire that's fully involved. I put the words up there, so if you did take pictures, it would help understand the slide a little bit better. We have burn cells in Toronto. We have to, prove to our management, prove to our members, prove to our union, our health and safety, what we're doing. And we lit this room on fire, and we waited for it to flash over, and we're showing the science behind our 1,003 liters per minute. So we wait for it to flash, and watch where that nozzle stream is going. And this is a 4-second blast, and it's a done deal. What was interesting about this was the fire investigators, and they filmed everything. The candle actually didn't even fall over that they used to start this fire. It's using the smooth bore, and it has to hit something. It has to hit the ceiling. It has to hit the back wall. And I'm going to explain that here in a second as well. This is a bad fire in Toronto. We had just finally implemented the 65 millimeter hose on every truck in the city. Mark Craig was on the nozzle for this fire, and I had trained him in high rise firefighting. This guy is truly on point. He's older than I am, by the way. And when he set the gate and gauge, he said, I only had 300 kPa on my gate and gauge, and it was open all the way. He needed 450 kPa to get that 1,003 liters per minute. So he's going in with 900 or maybe the high 8s. And he goes, I was scared because I knew what type of fire we had. You're going to watch this. You're going to see the flames come back inside the apartment here, and you're going to see a rapid knockdown. It gets sucked in when you open the door, it comes at them, it hit the ceiling, conditions change, and very little smoke cut in the hallway of this particular fire. So that was a huge win. Mind you, it was at the top floor. I wish all our fires were at the top floor, but it was a good day for us, and it kind of showed us the science. Because of this, my apologies, we came up with a scheme of making entry into the fire unit, and I'm just going to let this play. So what we do now is we come up, we have 5 firefighters, we have 30 stories worth of hose. 30 stories worth of fire hose seems like a lot, doesn't it? It's 3 hose packs gives me 15. I come up with 2 crews, I have 30 stories worth of improvised standpipe. So we're going to come up to the door, and we're going to put our door control strap on it. Once we have our door control strap, because of what happened to us at Wellesley Street, we're good to go. We're going to force the door, pot on the stove. Drop your hose packs, let's go in and deal with the pot on the stove. Or we're going to come up to this door, and we're going to breach the door, garbage can fire. Drop your packs, stretch. We don't need to set our gate and gauge. We're going to go in with a charged 65 on a little tiny garbage can fire, and we're going to give it a squirt. We control how much water comes out by simply on what we do on the bail. Or there's going to be an ugly animal behind that door, and it's going to be a fully involved apartment fire. When I go to take that door, I'm going to flow the full potential of that nozzle right here. I'm going to hit the ceiling. So let's pretend that you are out here. I'm going to flow the full potential of that nozzle. It's going to hit the ceiling. It's going to turn into a giant pizza slice. It's going to track until it hits something, and it's going to drop. And I'm taking the largest square footage out of that apartment simply by that door. My next movement, I'm moving in 5 feet. It's called a clamp slide. I'm moving in 5 feet. I'm going to flow the full potential of that nozzle again at the ceiling. I'm going to hit the wall, and this fire has been done. It gives me a hallway, a kitchen, and possibly 2 doors, like a bedroom and a second, or a bathroom, simply by going in 5 feet. The other thing that we were struggling, and we teach this at the fire academy, is you're going to come in the room, the fire's in the back corner, and we're taking the nozzle, and we got a pinch point here. We need a firefighter staffed up there, and we're going to make the right here, and I need a firefighter staffed up here, and my fire is right there at the end, and now I'm going to open the nozzle. We've been taking the nozzle to the fire. We haven't been taking reach of stream. For me now, to get that same fire and avoid 1, 2, 3 pinch points, I'm hitting it from right here. If it's a hoarder, perfect. I have the ceiling. I'm flowing water at the ceiling, and I'm hitting that fire from 100 feet away. This room is not 100 feet. This room is 50 feet. So imagine this room times 2, that's my reach of stream. So I'm hitting the fire quicker, I'm knocking it down faster, and it's safer for us, and certainly safer for the occupants. So watch John. John's 63 years old. He's going to make entry into the fire department. There's our door control strap. I'm standing at 90 degrees to that, and I'm getting drowned by John. He's going to flow the full potential of that nozzle until conditions change, until he's able to move forward. If he can't move forward, those windows fail, it becomes wind impacted, we pull the door control strap and we reset. Here's a view from the hallway. That reach of stream is powerful enough to actually open that automatic door closure, That door's only open 8 inches. I'm hitting the ceiling. It's tracking 100-foot reach of stream. Remember that. This room is 50 feet. So twice this room. A second here. There we go. So I wrote this up. You can take a picture of it. You can look at the UL studies. I'm not making this stuff up. The UL studies are fantastic, and it talks about the advantage of flowing from outside a room versus inside a room. But water travels in 1 second, 100 feet. I'm not going to cycle that nozzle. I'm not going to water mist. I'm not going to pencil. I'm going to flow the full potential, but just knowing that it's going to take 1 second for that water to go from there to there, 100 feet. I need to test the glass. The balcony, the solarium, the windows. I need to test that glass. The room is superheated. The glass, when it gets hit with our water stream, will fail. And when it does fail, if it's wind impacted, I'm in trouble over here. We've eliminated that safety factor for us. Because if it does become wind impacted, I'm shutting the door. And I'm going to keep trying that same tactic until our other tactics that we're going to talk about come into play. If it is safe to move forward, and there's my buddy John. He's going to move in 5 feet, and he's going to tag that ceiling. It's what makes that giant pizza slice. And here's another view from the side. If I was backing John up, and I picked that hose up, I give John nozzle reaction. The hose is heavy. Leave it grounded. Keep it there. John's going to stand up. If he flows the full potential of this nozzle now, and we've all had those bad experiences as firefighters on the line, we're going to be knocked on our ass, right? It's 100 pounds of nozzle reaction. You cannot open the bail fully, or you will be knocked on your line. So John has half bailed it. He's 62 years old. The firefighter backing him up simply puts a foot on it. When John does open up the nozzle, it moves 2 inches. We need you to stand on that hose so it doesn't move 2 inches. Once it's flowing, you can actually take your foot off the nozzle. Or, sorry, off the hose line. Where are we now? There we go. Here's a back view of John. Now he's doing overhaul. He's got half bail, quarter bail. But we teach our firefighters that when you're in that overhaul, when you're in that hydraulic ventilation, you can stand. And you only open up that bail till you feel that nozzle reaction, and then you stop. If you need more than what John's flowing here, you take that nozzle reaction back to ground. Hydraulic ventilation can be done with a smooth bore. There's a 200 CFM difference, and you can go on the UL website and see those stats and statistics. In that initial kit that I showed you brought up, we have a Havilland, we have our irons, we call it, a flat-headed axe. If we're unable to make entry into that apartment, we call it Havilland piking in the door. We'll drive a hole in that door. We'll flush mount a 1 1/8 tip. And you have to try this because you can see it's pretty sloppy. And we'll flush mount that, and we'll continue to flow water until the high-rise unit gets there, and we can put all our other tactics into play. A little bit of a delay here. It's coming from Canada. There we are. So this is typical what it looks like if we have a class 1 system or we're forced to go from the floor below. And with these new buildings, and I had a good tour of the City of London last night, and I walked some floor plates, and I was trying to get an idea of what the firefighters here have to go through. And man, it's not easy. It is not easy. You certainly have your hands full. My hotel room, I was shocked to find out that the doors are outward swinging. In our country, every single fire unit is an inward swinging door. Every single exit stairs is an inward swinging door. If it's an outward swinging door, I know it's a utility room. So in zero visibility, when I'm going down the hallway, inward, that's a unit. Inward, that's a unit. Outward, that's utility. But my hotel room has all outward swinging doors. That's a problem. The next problem is I have the good opportunity of coming up short. Most apartments now, when you come up short, you have to go back to the standpipe valve. You have to shut it down. You have to add your length, and now you're truly moving 250 feet to 300 feet of charge 65. The best disciplined firefighters will have a hard time moving that line, especially in bad visibility, especially when you're tired. So what we're teaching our firefighters, you need to flow that line. You need to use the reach of stream. You shouldn't be more than 100 foot short on your stretch. Generally, you're 50 feet, worst case scenario. You have a 100-foot reach of stream. You need to flow that line. If you are short, and again, I put a lot of wording up there, so if you were to take a picture, when you are short, my objective is to get that door closed and tag the door frame. 50% of what I sent downrange is going to come back at me. I'm almost at 180 degrees to that nozzle inside the room, and I'm getting wet. Simply by tagging that door frame at 1,002 liters per minute, I'm getting water in that room. My objective now is to get downrange and close that door. If I can get that door closed, this fire resets. I can staff up in front of that door. I can change tactics. I can get my door control strap on, but I stop the process of combustion from going down the hallway and going up the stairs. And this is how we do it. We have a removable tip, which gives me a 38 millimeter connection. I can add a 45 millimeter hose if I wanted to, but we're gonna add an increaser and we're gonna add the 65 again. And that's what it looks like. The weak point in this is the bail. We need to secure the bail. We have 5 squads in the city of Toronto. Their boots love to come and kick those bales closed. So we have and this is how we do it. I'll just let this video play. So we have 2 firefighters. We have 5 up top, we have 1 on the line, and 1 is backup. That's it. If we put the 3rd firefighter on it, it slows the forward progress down.
Call for water.
Overwork or she's going to overwork. There's no nozzle reaction on this. They've taken that nozzle reaction to the ground. They're flowing 1,003 liters per minute. That firefighter moves the tip 1 inch, 100 feet away. That gives 10 feet. If he moves it 2 inches, it gives him 20 feet. Hallways generally 4 to 5 feet. So it doesn't take much movement. That second in crew, the backup crew is coming up. They have the opportunity to add 150 feet. Like I said, in most cases, you're only 50 feet short, but if you have an underground parking garage, you're going 150. So we have the tip removed. We were flowing 100 foot reach of stream. We remove the tip. We lose reach of stream down to 80 feet, but we're actually flowing more water. We have more protection. We just lose reach of stream. We add the increaser. We're still able to flow water. Our eyes and ears are still on the fire. We're still working. We don't have to go back and shut the standpipe system down. It takes time. When it's safe to do so, and your experience will tell you, if that fire is at 80 feet away from it, which is twice the distance of this room, now it's safe to add. We're always under the protection of the nozzle firefighter. Now we're going to send it. We don't need to talk to each other on the radio. We can talk to each other face to face, but we're sending the water forward to the nozzle firefighter. That's John again on the line. He's 63 years old. He's going to do the clamp slide here, which is very difficult. I recommend not to try it. It's hard. We do a high heat, low drag now. And we're going to secure the bail. Every single one of our HighRise packs has 3 straps on it. We have 9 opportunities to secure that bail. And in our standpipe kit, we also have 32-inch twist ties for securing the bail. We have a plan A,
and then you guys go back them up?
Oh, it's him talking. That's me. Sounds like you, doesn't it?
Flow, John?
So, with our tactics, our crews are all bringing up this 1, 2, 3 lengths of hose and the standpipe kit. Ignore the tactics bag. That's for the HighRise. If I want to change tactics, I'm simply bringing up something to put on the end of it, and that's a 65 millimeter Bresson distributor. The tactic that we use for this is our fire attack crew is using a riser 2 floors below when we go to use this tactic. In our country, we can take 2 65s off 1 riser. So if we do a special tactic, we're taking from the 2nd riser or the 3rd riser, we're taking from any other riser other than what the fire attack team is. We're going 2 floors above the fire, and we're going to deploy the Bresson distributor. We're putting 800 liters per minute in a wind-impacted fire that we're unable to make the push down the hallway. If we get up to 2 floors above the fire and we see this happening, it's not an ideal placement. We break that window or we breach that window, we're going to allow those flames to come in. We're going to go 2 floors higher. If you start considering man, how high are you going to go? Just remember that we have 30 stories worth of hose on every, we do have 30 stories worth of hose because we brought in 2 crews, but each crew has 15 stories worth of hose, 150 feet of hose. Have we ever done it? Absolutely. So this fire here was a stubborn fire. It was on the exterior of the building. It's not a Grenville. It wasn't exterior cladding. The heat release rates, I mean, we're talking 2 different animals here. But this animal here was on the exterior of the building. It was communications cable and wiring. And you can see hose lines. They were trying to flick the water around the corner. There's multiple firefighters in there. And when I got to this fire, I looked up and I said, where is that fire going to be in the next 12 minutes? I need to get above that. Why 12 minutes? So in our city, we time every single thing that we do. The arrival time, the A2 time we call it. So when I get to A2, that's the fire location. When we get to A2, it's timestamp. So I know that if I ask a firefighter to do anything in a high rise, it takes 12 minutes. So in 12 minutes, where is that fire going to be? So in this case, I went to the roof, we deployed the Bresnan, and it worked. I teach this tactic at H-Rock. Here's what it looks like. Hope the video goes a little squirrely, that's okay. But I get 60 feet of coverage out of that Bresnan distributor. I'm going to just fast forward. All our nozzles are 350 kPa. It makes it simple when we're using the 65 millimeter hose. That's the floor below nozzle. It flows 900 liters per minute. It's a smooth bore, and it's the same 1 1/8 tip that's on our attack package that we're making entry. So if I hit it from the outside with a 1 1/8 tip, or hit it from the inside with a 1 1/8 tip, it's doing the same amount of damage on the interior. We're no longer scared to hit water from the outside. This is the Gosford fire. We used it. Unfortunately, at this fire, it spread through the outside. Multiple apartments were on fire and was going up the outside of the building. You can see the floor below nozzle in action here, but we were able to put out 3 stories in 12 seconds with the amount of water that we were putting on this fire. The tactic is similar to the Bresnan distributor. I'm just going to fast forward this out of time. We can use the floor below nozzle inverted. It has nozzle reaction. We have to use our door control strap. No extra special equipment is needed. It's all in the Standpipe kit that weighs 22 pounds. But we'll reverse the floor below nozzle. We'll have a 100-foot reach of stream, and that's our plan for exterior cladding. We have a 38 millimeter Bresnan. We can do wall breaching. We have a 4-inch coring tool that we'll make holes in. It's battery powered. We use it for residential house fires, but that's what it looks like there. We can go floor, ceiling, wall. We have multiple options. This is the Baldwin Street fire. We brought our high-rise packs to the roof with our Standpipe kit, even though it was not a Standpipe equipped building. We drop our length off the roof. We get water quicker and faster and in great quantity. When this building did collapse, it pinched our Bresnan distributor, but it showed the effectiveness of getting that water up to where we needed it. This is our opposing tip nozzle. Again, 160-foot reach of stream. It's got a 1-inch tip. It cuts through cellulose. It cuts through the pink foam insulation. It's fantastic for hidden voids. This is our standoffs on our exterior cladding. We find the 1/2-inch tip will fit. Again, no nozzle reaction on it. We'll core a hole from the interior exterior, and we'll get that nozzle in there with a 160-foot reach of stream, and it will start flowing. This is the Baldwin Street fire. It's a residential house fire. We're using our HighRise Tactics at house fires. There's a roof-on-roof parapet, and we're flowing water, and we're going for the kill. Our portable monitor, again, the same hose packs, the same everything. I'm just taking that nozzle and adding that to it. And now I'm flowing 2,000 liters per minute, which is the maximum on Grimwood's megawatt chart that we had. This is us training with it. That nozzle takes nozzle reaction to ground. So I still only need 2 firefighters on that line, 1 on the nozzle and 1 keeping the hose grounded. We just did this the other day. I showed some colleagues last night of a 12-unit fire where we had to use this tactic. We ended up adding to the front, and my crew did it absolutely effortlessly, and it was a huge win for us because we needed that fire to help confirm our tactics. Another tactic that we used, and you'll see, we have 1 firefighter on the nozzle. We have 1 firefighter keeping that grounded, but we're gonna flow, we're gonna hit that header, we're gonna hit that lintel, and Under proper operating pressure, we can hit the 7th story with 1,003 liters per minute and start putting water on the fire quicker. Because if I don't do this, where will that person in that unit be in the next 12 minutes? I have to go interior regardless, but if I can get water on that fire quicker, if not, they're going to have to wait 12 minutes on a standpipe system that I don't know works or not. So we're actually doing both. We can flow from the exterior, we can flow from the interior. I'm going to have to skip catastrophic failures, but we have a plan in the city of Toronto for it. That's what the plan looks like there. It's 4 FXD extinguishers. It's 600 US gallons that we can put inside the unit. We have a battery-powered stair climber that can lift it. We can refill that system off the standpipe head pressure that's left in the building. We've used it. You can see it using there. What I want to talk about is we can repeat the same tactic. We can put our second line into play. We can do wall breaching, portable monitor, floor below. I mean, it goes on and on and on. But we're using big water in the city of Toronto. This is Paul Coombs. His cartoons are truthful. I like it. But we have faster knockdown now. I think we're almost out of time, eh, Russ? Pretty close. 5 minutes? Oh, perfect. But we're getting water on the fire faster. And my team, they go, Brooksy, how long does it take to do a floor below stretch? How long does it take to do a hallway stretch? Are you sure we shouldn't keep bringing the can? And I'm going to leave this up while I talk. And my crew does a floor below stretch calling for water in 58 seconds. We do a hallway stretch in 38 seconds. So can I wait 38 seconds before opening that fire unit door to give a punch that's good for the majority of our fires? And the answer is yes, we can. And our fires have drastically changed. So you can take a picture of, this isn't on my website yet, but it will. But because of what we've done with Calgary Fire, and I'm doing it with Moncton Fire and 9,000 Toronto firefighters, we can see the difference that it's making, and we can do it effortlessly. And when I talk about making that big line, and I'm taking the big line, and when firefighters get here, and I'm at a dead end, and they say, take that line back, we're going to move and bend that line. We're fighting static pressure right now. Or I'm going to push the line. I'm going to make the turn. We're fighting static pressure. If I get to a dead end and I grab that nozzle tip and I stack the nozzle tip, the hose weighs nothing. It's a basketball. It's 120 pounds worth of water weight. But if I keep the hose stacked, it weighs nothing. And I can take that 50 feet with one firefighter back. If I have a firefighter on the loop, it'll come back even quicker. The tighter the hallway, the better, because that hose will actually slide against the wall. And the prop that we made is a 40-foot long hallway with multiple turns, and I showed some of my colleagues here, and we'll go in with the Blitz Fire 2,000 liters per minute. The same 2 firefighters will stack that hose line, and we'll bring it right back out again. It's made a huge, huge difference. So I'm proud to say that our high-rise fires went from 16 minutes to 6 seconds now that we've switched to this hose and nozzle package. If we look at, there's some things there. You have a clear hallway, you have a dirty hallway, you've come up short, you're unable to enter the fire unit. We have multiple options. I put them there. If you have a no water scenario, the improvised standpipe, we have 8 options if our standpipe building fails. Our option A is the building's fire pump. Our option B is our fire pump. Our option C is pumping into the ground floor standpipe for water supply. Our next 8 options all have to do with our standpipe kit and hose. Again, a lot of this stuff, especially for the firefighters, again, it was a hard sell on our job because we've had bad experiences. If I put 4 of our biggest, baddest firefighters in this room on the line and I push on the nozzle, I'm moving the last firefighter. And you'll see the hose bend where it goes to ground. If every firefighter lets go of that hose and grounds it, and the front firefighter takes that nozzle action to ground, it becomes effortless. And that was the key, and we saw it in our recruits, is we're going in with 5. We're going in heavily staffed. We all have a position, but we're keeping one on the nozzle, one on the line, and we haven't lost our forward progress going forward, but it's something that will be so difficult for change if you decide to go that route, because it's in our memory. It's the way we've been trained. But I can tell you it's made a difference in our city anyways. You have different issues, but that's my contact. It's just highrisefirefighting.com. All the stuff I put on my website is free. It does need updated. I have a presentation on the Bresnan. I have a bunch of good stuff. Help yourself, it's free. And if you do contact me and I don't get back to you, just keep trying. I will answer all my calls. Sorry for the rush presentation, but that's what I do. Thank you, everyone.
Book your tickets now for the 8th International Tall Building High Rise Fire Safety Conference, taking place alongside FDIC in Indianapolis, US, on the 15th to the 17th of April 2024. 3 days of world-class speaker presentations, debates and networking. Book your tickets via the website www.tallbuildingfiresafety.com. Early bird discount tickets will be available. The Tall and High-Rise Building Fire Safety Management course is ideal for anyone who has responsibility for fire safety management in tall and high-rise buildings. It is a 5-day intensive course with world-class instructors. You can get full details of the course on our website www.tallbuildingfiresafety.com.